Christian, I invited you over here to the backyard to cook you a breakfast without using a regular stove.
But how would you do that?
Well, I'm going to use the heat of the sun. See, the sun is shining on us, right? And it's warm, but it certainly isn't warm enough to cook an egg. So you have to take that same amount of heat and concentrate it somehow. And over here I'm doing it with a parabolic reflector.
What's a parabolic reflector?
Well, that's a certain type of curve designed in such a way so that wherever the sun is here, it's focused right over there on the bottom of that little pot.
So that makes it really hot.
Really hot. In fact, I'll put this piece of paper underneath. You burned a hole right through it.
Wow,
Yeah.
hot.
So, well, as a matter of fact, look, in the bottom of the pot.
There's water boiling.
Yeah, there's water boiling. So you and I are going to poach an egg. So would you break the egg on the plate there?
Sure.
And put it over in the pot. Okay.
Ugh, gooey.
Okay. Here's a napkin here for you.
Thanks.
You can wipe your hands off. Whoop. We're going to leave the egg right there.
To cook?
No, this eggshell, because I want to use the plate because we got some more stuff cooking over here. Come here.
Ah.
You recognize these?
They're funnels on a stick.
On a stick, yes. But on the top of the stick is a toothpick, and on the toothpick,
A hot
see what
dog.
it is?
Yeah.
You want to reach and get one? I think they should be done.
Are they going to be hot?
Well, I don't know. Feel it.
Well, they're kind of hot.
Yeah, they're kind of warm, right?
Ah, that one was hot.
That was, okay, here, let me get this one.
Ah, thanks.
Okay, there's our protein. Now come on over here. This is an oven. What's happening to the light here?
I suppose it would bounce off, and then it would go in through
Go inside
hole.
there. In this case, the box you see is lined with newspaper as an insulator, and inside there I have rolls wrapped in aluminum foil. You could actually bake a cake in there.
Yeah.
You want to take out one of the rolls?
Sure.
Warm?
Yeah, it was warm in there.
Okay. Then here's the last one. Come on around over here. So this is one you could make at home because it's just a piece of cardboard rolled into a funnel sort of shape. See, and then lined with aluminum foil. Put your hand at the bottom there.
Aha.
Yeah, feel how warm it is?
Yeah.
And what I had in there were pieces of apple. So we're having nice cooked apples. So
Oh,
here, I'll put
yum.
the cooked apples on the plate. You take it back over there to the picnic table, and I'll bring you the egg.
Okay, thanks. Boy, these are really nice.
Okay, here you are. One egg coming up.
Can't believe this is done by the sun.
That's right. Take a taste.
Very good.
Thank you. This is an unusual view of an ordinary kitchen helix. You're looking up inside it. A helix is a spiral-like curved line that forms circles of increasing size around a center, in this case 2 centers. While a spiral has 2 dimensions, a helix has 3 dimensions, so it spirals through space. This helix is a springy egg beater. Now, here, get this one nice and high. Okay, then set them both down on the table. Okay, quick. There.
Okay.
But the big question is, how come the water goes uphill? When you have this glass up here like this, the water must be going uphill to get over there. Water doesn't flow uphill. You know what this is called, first of all?
Siphon?
A siphon. Yes, a siphon. And people use it to transfer liquids from one container to the other. And to start it, you fill the tube with water, put your fingers on the end, put both ends under water, and then let go, and the siphon starts. Now, many people are sort of puzzled as to how a siphon works, and maybe if we make a siphon out of a chain, it'll make more sense.
Okay.
Here's the glass, and instead of water, the supply of water, here's the supply of chain. Okay. Here, hold it up like that. Now, nothing is happening, right?
No.
Okay.
It's just
If you pull a little more chain out, a little more, there.
Oh.
Okay, now why did it start going?
Because this chain is heavier than the chain in the glass.
That's right. Because that chain is heavier.
So that must mean that the water is heavier than the water in the other glass.
Right. Here's the low side of the siphon, right? As soon as the water from that part of the siphon weighs more than this water over here, then it'll start going.
There it goes. It pulls it all out. That.
So now you understand it's the length of the column of water that's greater over here, so the water starts flowing down here and in effect pulls the water up.
Yeah.
Okay. Now you can have a lot of fun with different kinds of siphons. Come on over here. See if you can figure out what's going to happen with this one.
Well...
Here is a supply of water here in this pitcher. Okay, now watch what happens. I'll raise this, and you watch.
Spouts almost all the way up.
Yes, and this is really a siphon, but it's got a sort of an air bubble in the middle.
Yeah, and the air comes through bubbles in here.
Well, we're bubbling some of the air out of there, and that's why you see bubbles coming down here. But because we're siphoning the water up here, it's going up into this little tube. So this is kind of a fun siphon to make because it makes a little fountain in the middle.
Siphon. Yeah. That's neat.
Yeah. Then you remember how I told you how to start a siphon?
You have to put your thumbs on the edge and put it in.
Not always. Take a look at this one. Here's a soda straw, you know, with a bend in it. Watch what happens when I put water in here. Nothing's happening.
There's an air bubble in there.
You think that's what it is?
Well, there wasn't one in the one over there.
Okay, so when do you predict that it'll start flowing?
When it hits the top of there, so there'll be no air bubble in it.
See if you're right.
Yep.
There it goes.
There.
So this is a self-starting siphon. So when should it stop?
When hits the bottom, because then all the air will come in and there'll be an air bubble.
Right, as soon as it runs out of water right there, right?
Yeah.
See if you're right. Sure enough.
There.
So there's a self-starting siphon.
See, there's liquid left in there.
Yeah, there's a little liquid in there, and that's why it started. Just to make sure that you understand now the principle of a siphon, here's the typical one you can make at home. And what happens when you raise one of the glasses?
The water, when it gets
Because
heavier.
the weight of the column of water over here is heavier, it starts to flow.
And it pulls the water
out
here
from there.
because there's no air can get in to fill up the space.
Okay. Anyway, that's the idea of that thing that's a lot of fun to do, a siphon. The destruction can be staggering. Houses, even block after block, can be completely leveled by some of the strongest winds that can occur on Earth, the violent winds in a tornado. Records show that this area of the United States is hit by more tornadoes than anywhere else in the world, and is therefore called Tornado Alley. Scientists don't know exactly what causes such storms, but they do know the general weather conditions that spawn them. Warm, moist tropical air colliding with dry, cold Arctic air, the same conditions that produce thunderstorms. When the high winds within a thunderstorm begin to spin, a funnel-shaped cloud can form. As the swirling mass of air picks up speed, a low-pressure area near the center picks up dust and debris, turning the cloud into a dark mass. The partial vacuum at the tornado's center can cause the air inside a building to expand so rapidly it can literally be blown apart. Weather forecasters issue a tornado watch when they detect the conditions that are favorable for the formation of a tornado. A tornado warning is issued when one is actually spotted by an observer or on weather radar. A tornado is usually preceded by this hook-shaped cloud image on the radar screen. With a tornado warning, people are advised to take cover until the storm passes, which can be in minutes or hours. The damage can be to a few buildings or along a path of destruction that can extend for miles. The fact that these violent storms are so unpredictable adds to their danger. More research into the weather conditions that spawn them may help pinpoint when and where they will strike and save lives endangered by that most frightening of storms, the tornado. So we have Matrix Madness loaded into the PC Junior, and You know what a matrix is?
Not really.
Well, you know what madness is.
Yes,
well,
I do.
You'll soon find out what a matrix is. All you have to do is push 1 to get level 1, and we can start playing
All right.
the game. That is a matrix.
Okay.
You've seen those kind of games, haven't you?
Yes, I have.
That you have to fill and find out what goes in that empty square up there. In this case, you have 2 choices. You want to make a choice?
Well, it looks like it's kind of going in a pattern. It's going 2 circles together and then 2 circles apart, and then in this one it went 2 circles apart, 2 circles together, 2 circles apart.
Okay.
So it's going to be 2 circles together.
Okay, so you push that
That's
choice,
right.
and it's correct. Okay, now notice it'll automatically keep your score also.
Okay.
And now you want to push it again. We'll just go to the next one.
Okay.
Now, one thing we didn't point out is, see down there in the lower right-hand corner,
Yes.
100, 98,
Yeah,
97,
right there.
96, and so forth. So you have till it gets to 100. So you have all that time to make up your mind, and the faster you do it, the higher your score.
Oh, I see.
Okay. So now what are you going to put in that empty square?
Well, there's...
You have 3 choices this time.
Yeah, I think I'm going to put it this line because the number 3, because it goes 2 lines all across, then it goes 1 line.
1 line all across, and then
3
3.
lines, so I'll just
Okay.
put number 3. And I was right.
Correct. Okay, push the next one. Now this is a fairly common, there are simple versions of this which you find in comic books. They have 3 cats and a dog, and the little kids are supposed to find out. Why would you want to play with a game like this?
Well, I guess if in math sometimes you do number sets, like they'll say 94, 78, which number will come next?
Yes. Well, but that's a math problem. I just wondered if you realize what value it has sort of in your everyday thinking.
Well, they give this kind of stuff on IQ tests.
Yes, IQ. What it really amounts to, Stacy, is the ability to look at a pattern and recognize it in the first place, and then make some judgments that sort of tests your logic, and that's why they have them in intelligence tests.
Oh, I see.
Because they want to find out how logical you are. And this, of course, doesn't have any words in connection with it, no pictures. All you have to do is recognize sort of things in limbo, or things that don't have any connotations around it. So it tests basic logic rather than your knowledge of words. You've got to make a choice here. What do you got? 42 left? Okay.
Yeah. So I think I'm going to put in number 3.
Correct again.
Yeah?
You're a very logical young lady.
Oh, thank you.
Michael, as I remember, you had some experience right here in this very spot with a pendulum.
Yeah, the one that almost hit me in the
Yeah,
face.
the can?
Yeah.
No, it didn't really.
Well, almost.
This time we have 2 pendulums.
Okay.
Here. Okay. Give them a swing, see what happens.
Okay. They're both swinging in sequence.
Right. They're sort of in step.
Yeah.
And why is that? Because you started them in step, right?
Okay, yeah.
Didn't you? Stop that one and then get it going again out of step with the
This
other
one?
one, supposedly, yeah.
Okay.
They're exactly opposite, but staying in step, aren't they?
Yeah.
They're both coming to the center point at the same time. And why is that, do you know?
I don't know.
Because of the length.
Of the rope?
Yeah, the length of the rope.
Okay.
The length of the pendulum determines its period. The period means the time that it takes to go back and forth.
I see.
Okay, now that's sort of the groundwork. Now I have a little puzzle for you. Here's a piece of wood, and I'm going to tie the 2 pendulums together like that.
That won't do very much, will it?
No, because they're exactly the same length, right?
Yeah.
But this time, instead of swinging both, I want you to swing only one. Wait,
Okay.
What'll happen?
Well, they'll both be swinging then.
Okay, try it. Now you only gave one a swing, this one right here, right?
Well, that one stings like just in the same place, and this one's swinging.
Yes, but now watch what happens to that one.
Well, it's starting to move.
Starting to move, right?
Yeah. So eventually this one will probably stop.
Right.
This will start swinging.
That's because you see you're transferring the energy via that stick over to this one.
I see.
And if you let them go long enough, the energy would be transferred back again.
I see.
And it'd transfer back and forth and back and forth. Okay, now a different kind of problem. You want to hold that stick for a minute?
Okay.
Because That time, both pendulums were the same length. But now, you should now be able to tell me what's going to happen when this one is shorter.
Well, since the rope's shorter, the time period of that should be longer. So it'll swing
Take that one again.
faster.
Just to make sure I understand, what did you say?
Well, the time period will be shorter.
That's what I thought you meant to say. That's
Because
what you
it'll be
meant to say,
faster,
right?
yeah,
Right.
it'll be faster.
Okay, so give them both a swing. Here, I'll
Okay.
take the stick.
That one's swinging faster
Yeah.
because it's got a shorter rope.
Right, got a shorter rope. Because the length of the pendulum determines its period. Now they're almost in sync, you see that?
Yeah.
But they soon got out of it again. Okay, now comes the real puzzle. Here comes the stick again.
Well, that'll be just like the other one, except that since this is shorter, well, I'm not sure. I'll try it.
Okay.
Okay. Well, this one's staying stationary, and this
Almost.
one's
It's
swinging.
moving a little bit, yeah.
It's not,
We're still transferring the energy via the stick.
yeah. But this one doesn't seem to be moving as much, though.
Why not?
Well, the rope is shorter, so it doesn't have the same time period.
What we're doing is we're giving that one a push over there, but in the wrong time. It's not giving it in a push
Enough.
at the right moment,
I
right?
see.
So it will transfer some of the energy, but never enough to get it actually swinging. And this will eventually stop, and that will eventually stop. Well, this one was a lot safer than the can coming up, right?
Yeah, it was.
And you did very well, too. Congratulations.
Thank you.
Is a tomato a fruit or a vegetable? Well, you know that inside a tomato are seeds. So to a botanist, it's the fruit of the tomato plant. By this definition, many vegetables, beans, peas, peppers, and tomatoes are all fruits. But by court decree back in 1887, tomatoes sold for food were officially classified as vegetables. So on the vine, it's a fruit, but on your plate, it's a vegetable.
What are you doing with the red cabbage juice?
Think I'm eating sauerkraut or a coleslaw
Yeah.
or something? Well, that's what people usually buy this stuff at the supermarket. But I'm extracting the juice because we're going to use it as a chemical.
Chemical?
Yeah, to
For
do some
what?
chemical experiments.
Okay.
Well, you're going to use it to help solve the question of what are those liquids, either acids or base. Now, first of all, what's an acid?
Well, it's something that eats things away.
Yeah, okay, that's sort of one definition. How about a base?
That's the opposite of an acid.
Okay, it doesn't eat things away.
Okay.
Well, let's go with that different definition for the time being. And now tell me, can you identify this from the smell?
Vinegar.
Okay, is that an acid or a base?
That's acid.
This is sodium bicarbonate dissolved in water.
That'd be a base.
This is well, here, I was going to tell you, but you can smell it.
That's ammonia.
Ammonia. Is that an acid or a base?
That's an acid.
And this is grapefruit juice.
That's an acid, too.
Okay. So, 3 acids and 1 base. Okay. You said the sodium bicarbonate
Yeah.
was a base, and the rest are acids.
Okay.
Have you ever played with litmus paper?
Yeah, we played with it in class one day in science.
Okay. Here is a picture that says acid on it. Okay. And here's a picture that says base on it. So we know they're acids and base.
Okay.
So scientists can use the simple thing that tells acid or base using litmus paper, but they also have a universal indicator that will change color depending on how acid or base something is. Because all this did was one or the other. It's acid or base.
So this will tell whatever it is?
Well, it'll
Anything?
give you a whole range from medium acid all the way to a strong base, depending on the
see.
color. So, by the way, this acid and base that we were working with here, this happens to be
Vinegar.
vinegar, and this is sodium bicarbonate.
So I was right about the vinegar.
You were vinegar and the sodium bicarbonate over there, okay, because I identified them for you. So let's use the universal indicator and pour some of the base, 5-10 millimeters in the bottom of there.
Okay.
Okay. Put in some of the universal indicator and stir it up.
Just pour it in?
Well, here, take this nice long
Okay.
medicine dropper.
Turns green.
Yeah, it turns green.
So that means
We identified that as a base to start with, so a base turns the universal
Green,
indicator
okay.
green. Okay, so that's all that you need of that, because now you're going to start, let's say we want it to be an acid. So what are we going to do? We have to add an acid, but we have to know when it becomes an acid. So you can tell by the color change. Go ahead. Just pour a little bit in and stir it at the same time. A little bit.
oh
Whoop. Changed there for a while, didn't it?
yeah.
But it went back to green again, but a lighter green. Also, you can tell from the bubbling the chemical reaction is taking place. Yep. Cherry soda.
That's more of a yellow.
Yeah. You should get it when that's sort of probably considered neutral. Ah, now you're getting a nice and pink. And notice the bubbling has stopped. That means the chemical reaction has stopped too. Okay, now you got a
Now
nice
it's a
and
red.
pink. Right. So you see, a scientist could adjust the chemical that he's working with. You have whatever pH, that's a measurement of the acidity, to whatever he wanted.
We could actually measure how many pHs there are in our water at home.
As a matter of fact, let's do that.
Okay.
Here, go fill this one with water from the sink over there.
Is this good enough?
Fine.
Okay.
Now this one, I wondered whether you were going to ask about that, and I filled
What
this
is it?
one with distilled water.
What's
Theoretically,
distilled?
well, it means that it's been boiled and into steam and condensed back into water again to leave all the chemicals behind. So
I
put
see.
some universal indicator into the distilled water, and that'll show you what chemicals or water without any chemicals in, what the color is. So stir it up a little bit.
Well, that's yellow.
Look what happens when you do our tap water.
Oh,
It's very definitely alkaline, right? In fact, some water coming out of the tap might be slightly acid, and others might be slightly base. If the water seeps through various kinds of soils, it can pick up bases from the soil or acids from the soil. Well, now we have that problem over here, right? You were making some guesses as to which was which, and we're now going to use our homemade indicator, cabbage juice.
And
This
one's
first one was vinegar, and you
it
said
was
that
an
was going to be an acid. Okay, that's what happens when you use red cabbage juice and an acid. Now here was sodium bicarbonate, which you know is a base.
It's purple. Oh,
Yeah,
oh.
pretty color, right? Add a little more. Definitely on the blue side and purplish. Now here was ammonia, which you said was what?
An acid.
An acid. Aha!
Green means a base, right?
Yes. So the definition of whether it eats something or not really doesn't work. The real definition is the acid contains hydrogen and has a sour taste, as far as everyday tests are concerned. Then chemists have other definitions as well. This is grapefruit juice. What do you think that one's going to be?
I think that's an acid.
So it should turn pink?
Yeah.
Aha, you were right. Very good, Michael. Anyway, it's kind of a lot of fun, isn't it? Because you can
Yeah, it
make all
was.
kinds of pretty colors. And the only one you were wrong with was ammonia. But these are the kind of tests you can make with a homemade indicator with red cabbage juice.